Well, hello and thank you for joining us for Leister's Industrial Heating webinar hosted by Jason Sanders. My name is Joseph Tarver, the marketing specialist, and I'll be your moderator for this exciting webinar today. Before we get started, I would like to go over our rules of play to ensure everyone is aware of Leister's webinar etiquette. This webinar is being recorded and will be made available to you once the webinar is concluded, making it convenient for you to rewatch any specific segments. We do ask that you keep your cameras and microphones off during the duration of this webinar in an effort to limit any distractions to both the presenter and/or other viewers. If you have any questions, please feel free to type them in the chat box, and either I will answer the questions myself, or I will direct your questions to Jason during the designated Q&A time slot. And without further ado, I'll go ahead and hand things off to Jason so you guys can get started. Enjoy, everyone.
Thank you for the introduction. Again, my name is Jason Sanders, and today we're going to be talking about the hot air blower category, specifically looking at a product overview, some items related to manufacturing requirements, some tips and tricks to help keep your equipment up and running. And without further ado, let's get started. So before we dive into the product overview, let's talk a little bit about why hot air. So hot air is used for a variety of different manufacturing applications to produce some of the products that we use in our daily lives. So think about your trip to the grocery store and look at the bottled beverages on the shelves. Look at the food and beverage items in bulk packaging, or consumer electronic stores when you see all those nice gadgets on the shelf that are made of plastic that have a protective packaging with plastic film. Or what about your trip to the doctor that is about to give you a shot for various vaccines? Those syringes that they use are all made of plastic. One of the common items that's used to produce those components is hot air. Now, before you can actually apply hot air to your product, to your process, companies spend a great deal of time looking at the different equipment, not only in their manufacturing line, but also understanding the requirements that they'd have to adhere to for their process. And having a good, sound understanding of what they're trying to achieve at the end of the day will help them make some selections for the equipment in order for them to achieve the desired results. Now, some of those applications use a separate heater and a separate blower to achieve those needs. But what if you don't have the required footprint for your manufacturing line, or you don't have the budget to acquire those tools, or you're just exploring some initial concepts? Well, that's where a hot air blower would actually suit your needs. And what is a hot air blower? Simply put, a hot air blower is a heat source and an air source combined into one unit. And our earlier renditions of our hot air blower consisted of a mechanical damper on the side to control airflow, and also a potentiometer or rotary dial on top of the tool to dial in your heat intensity. Now, both of those items actually help you dial in your manufacturing requirements and fine-tune the process a little bit more. Now, with all of those lessons that we have learned and all of the technology that we have in our portfolio today, we've been able to acquire some new tools for the hot air blower family. And we have in our portfolio today the Mistral, the Hot Wind, and the Vulcan. So now let's dive in a little bit more into the Mistral. Now the Mistral is a very powerful tool. It has the capability of running at 120 volts to 230 volts single phase with a kilowatt output range of 2.3 to 4.5 kilowatts. It gives you an airflow capacity of 3.5 to 14 CFM. Now the Mistral comes in two different versions, the premium and the system version. The system version, you gain a few more bells and whistles. You have the ability to take in control signals from a remote source, 0 to 10 volt or 4 to 20 milliamp. You also have the capability of supplying an alarm output contact to an external control system. And you also have the ability to take a look at the digital display that's on board with the unit itself to look at your set point values and the temperature readings of the tool. Now, with the premium version, right out of the box, you have the capability of making adjustments of your heat intensity from the onboard potentiometer. With the system version, you gain a little bit more smarts with the tool. So what do you get with the system version? Well, you get the capability of setting your temperature units, whether that's Celsius or Fahrenheit. You'll also have the capability of doing a temperature limitation of the tool. So say that you're running through your process and you don't want the tool to run at the higher end of the 1200 degree Fahrenheit range, but you want to back it down to 600 degrees. The tool will allow you to make those adjustments and settings and appropriately run accordingly. Now, in terms of the control type for both heat and airflow, you have the ability to tell the tool you want it to run from a potentiometer or from a remote source via 0 to 10 volt or 4 to 20 milliamp control signals. You also have the capability of talking about different nozzle loads. So as an example, if you are working with a small size nozzle or medium size nozzle, you can actually input this information into the tool and the tool will actually adjust the airflow needed for your process. Now, the temperature offset is a very interesting characteristic and a menu feature. So what this means is you have the capability of giving an offset of your temperature value. So say, for instance, you're running multiple tools on your manufacturing line. We'll use 3 as an example, and you see one of those tools is actually running a little bit hotter or a little bit colder. You have the capability of putting into the tool a temperature offset to adjust accordingly. That way you get a nice, even, uniform profile in your process. So now let's talk a little bit about a hot wind. So with the hot wind, it's got some very similar features to the Mistral. One thing to note is that it's available in 120 volt to 400 volt single phase, 2.3 to 5.4 kilowatt range with an airflow capacity of 7 to 32 CFM. Like the Mistral, it comes in 2 different versions, the premium and the system version. With the system version, just like with the Mistral, you have the capability of accepting 4 to 20 milliamps or 0 to 10 volt signals with an alarm output contact, and also a display to show the set point values coming off of the tool. Now, with the Hot Wind Premium, you've got the capability out of the box to control both heat and airflow independently because you have 2 onboard potentiometers. With the system version, you gain a few more features where you can actually fine-tune the tool for your process. As an example, you can set the temperature units, whether that's Celsius or Fahrenheit. You also have the capability of controlling heat and airflow either from the potentiometer or from remote control signals. Again, 0 to 10 volt or 4 to 20 milliamp. And also the capability of running open loop versus closed loop. We'll get into that a little bit later in the webinar, but you do have the capability of telling the tool whether what type of loop control you would like. And last but not least, let's talk about the Vulcan, the big brother of the category. So with the Vulcan, it's available in 230 volt to 480 volt 3-phase, 6 to 11 kilowatt. It's a very powerful tool. One thing to point out with the Vulcan is you only get 1 version of this, and that is the system version. So right out of the box, you have the capability of accepting 4 to 20 milliamp or 0 to 10 volt control signals and the alarm output contact. You also incorporate a digital display just like you would with the Mistral and Hot Wind system versions. Now, in order to do the setup on the Vulcan, it's a little bit different, unlike the the Mistral and Hot Wind system versions. Instead of having a onboard menu, you have a series of dip switches to dial in the parameters that you're looking for. So you have the capability of making adjustments for whether or not you want your Vulcan to read in Fahrenheit or Celsius. You have the capability of setting interface versus potentiometer mode, and also the capability of setting open loop versus closed loop. Now, we talked a little bit about the alarm feature that's on the system version of the hot air blowers. And what can you really do with this feature? Well, let's talk about how it works first. So the way that it works is you have an alarm contact that's on board with the unit. So it looks for a couple of different conditions. It's going to look for overheat of the body of the heater or the heating element itself. All right. So if for some reason you don't have any of those conditions, your alarm relay will actually energize and close the contact, telling you that it's okay to run the heater. Now, what can you do with that contact? Well, you can bring it into your external control system that's part of your manufacturing line, and it's going to give you some information to let you know that the heater is okay and you can continue on with your process. Now, what happens if you have one of those overheat conditions, whether it's the body of the heater or the heating element itself, or maybe both? Well, in this case, the alarm relay will stay in the de-energized state and your contact will remain open. Well, what does that tell you in your control system? Well, what that tells you is that you have a problem with the heater. Maybe there is an overheating condition of the heater, of the body of the heater or the heating element, or maybe there's something else in the environment that's causing the overheating condition. This is a good time to actually kind of stop your process and take a look to see what's going on and do a little bit more investigation before you continue on with your process. Now, let's talk about some of the more common applications and manufacturing considerations. So, some of the more common applications that we see are related to the food and beverage industries. As I mentioned before, bulk packaging for food and beverage products. Most of the times you see some sort of a protective film over those products. Think about your drink products that you see on the shelf, such as orange juice or maybe milk. Some of those products have been produced with hot air by applying hot air to the seals to close the products. Let's look at the automotive industry. So if you think about tail light lenses, there's a couple of pieces that kind of go together to create that one piece before it goes into the car. Sometimes it has a rough surface, a rough edge, and that may be because of something called flash or residual material. You can get rid of that flash by doing what's called a deflashing application, where you apply hot air to those surfaces to get more of a quality product. And also think about your automotive interiors, multiple types or multiple layers of materials being put together in a process called edge banding, where you apply heat to put those materials together before it's inserted into something such as a door assembly. Or in the medical industry, I had mentioned the syringe example earlier at your doctor's office, but think about some of the other tools that you see around your doctor's office. Maybe it's a blood pressure machine or any component that is made with plastic. A lot of those devices utilize hot air to either form them or actually do the final application where it's going to be deflashing those components. Now, one of the more common applications that we see on a regular basis is shrink sleeves. So in this video, you're going to see a water bottle going along a conveyor belt, and one of our hot air blowers, specifically the Vulcan, apply energy into the process where it's going to shrink the film around the body of the bottle. And one thing to point out in this application is it's just not the tool itself applying the energy directly onto the product. But more importantly, we're talking about some of the other accessories that are required for your process. So what you saw in the video was not only did you see the tool, but you also saw a nozzle. And why is the accessory consideration important? Well, right out of the box, you have a very powerful tool. And if you apply power to it and put energy right into your process or the material that you're testing, sometimes what you get is some undesired effects, such as maybe scarring of the surface or you damage the material. Again, this is not really what you want to do with your process. You're looking for a nice, clean, quality product at the end of the day. Well, in order to really achieve that type of results, you have to really focus the energy specifically into the material that you're working with. But you should really do that with one of our nozzles that we have in the portfolio. And what does that look like? Well, I've got my Hot Wind Premium here just as an example. And using one of our nozzles, it's a slip fit that's designed to go right onto the discharge of the heater. Okay, and what that's going to do is it's actually going to focus the energy right into the area where you need it to be and not blasting into the environment. Now, some of the other things that you should take a look at for your manufacturing needs. I briefly mentioned understanding the requirements for your process. So maybe it's a manufacturing specification for a certain customer, or maybe it's a quality spec, or maybe you're trying to reach a certain line speed. Having a good, sound understanding of what you're trying to achieve at the end of the day will help you make some tooling considerations for your process. Quality of parts always comes into play. Safety and appearance. More so for safety, you want to make sure that you have the right tool to produce the right quality of product so that end users can use them in a safe, efficient manner. Identifying roadblocks, pain points. Maybe you're in a position where you'd like to speed up your line, or maybe you want to change out some of the tooling. Trying to identify those pain points early on can help you make some decisions about where you want to go with your heaters, or more importantly, with the tooling for your process. And once you've gathered all this information, you can start to take a look at some of the options that are available for your process. But before you can actually start to select the tools for your process, let's dive a little bit more into the tool selection. So take a look at the current process, how you're doing it today. Maybe there's something you would like to, again, speed up on your line, or maybe you want to focus a little bit more on quality, and maybe there's something you want to change out with your existing tooling. Or take a look at your existing equipment. Maybe you want to improve upon something. Maybe there's something that you want to change in terms of your heater. Maybe your heating specification has changed, or your manufacturing specification has changed, and you now have an undersized heater. Knowing where you need to make some changes, that actually helps you make some educated decisions before you can actually do some tool selection. What other accessories are required? We briefly talked about the nozzles and how to apply energy into the process, but what if you want to add in something else, such as a temperature controller? All these considerations will actually help you make some educated decisions before you can move on with tool selection. Last but not least, manual to an automated process. So we talked a little bit about plastics and deflashing and how to get rid of residual material using hot air. Well, what if you want to automate that process? What if your process today looks like you have plastic parts going down a conveyor line, and at the end of the line, you have an operator at a manual station with a hand tool removing this residual material, but you want to automate this? You can totally do that with the system version of tools. But before you get to that point, you want to talk about the type of control that you have available with the system version of tools. We briefly talked a little bit about open loop versus closed loop, and in basic terms, open loop is taking one of our premium version of tools, applying power to it, the tool is running, and then you make your adjustments via the potentiometer. Now with open loop, you don't have the opportunity to bring in feedback from the discharge temperature or the process into an external controller. This is really what it makes that an open loop. Now with closed loop, it's a little bit different. Now it allows you for a little bit more, we'll call it precision tuning for your process. So in the example provided, we're talking about taking a type K thermocouple, which is going to be reading the discharge temperature of the heater or the process itself. Now it wants to send this information back into an external controller. It could be a single temperature controller, or it could be a PLC. Now, the external controller itself is really the workhorse of the process. So what it's going to want to do is it's going to want to take that information that's been provided by your TC, look at it, and then make the appropriate control signal adjustments out to the heater so that the heater responds accordingly and you get the temperature necessary for your process. Now, some maintenance considerations, things to think about to keep your tools running longer. A basic equipment check is a good place to start. So doing a visual inspection of the overall heater, right? So taking the time out to take a look at the heater, you want to make sure that there's no dust, debris, things that are being built up over time. But more importantly, maybe you want to take that heater tube out, the heater tube off of the heater to make sure that there's no signs of stress, like cracks in the element itself, or you got a good mica tube and the seal is just right. This is a good way to make sure that you can keep your equipment up and running. You don't have any failures during your manufacturing process. Now, what happens if you do have an issue with the heating element? Well, you can always replace the heating element on your own. Now, one thing to point out is using genuine Leister parts for replacement. And the one way you can tell that you have a genuine Leister part, especially the heating element, is that we have the Leister logo stamped onto the base of the heater along with the article number. That ensures that you actually have a genuine Leister part. Now, there are some aftermarket heating elements out there, and a lot of those products have been produced with inferior materials, which means that they could potentially fail in a shorter amount of time. Periodic inspection of your equipment. Another great way to make sure that you can keep your system up and running is taking a look at the air inlet on the hot air blowers themselves, making sure that it's clean of dust, dirt, debris. That way it doesn't get sucked into the body of the heater, right? And one of the ways that you can prevent a lot of that debris from getting in is having a nice clean air source. I mean, with a lot of manufacturing environments, we may not have all those luxuries all the time, but you can always put an air filter on the air intake to prevent some of those dust bunnies from getting in. Now, the picture on the right actually shows an example of a customer that did not take the time to actually inspect the equipment or put an air filter on the back of their heater. And what you see here is just basically dust buildup over time. And why is this important to showcase right now? Well, what's going to happen is over time, as that dust starts to build up, you could potentially have issues with the blower and potentially failure. Or you could potentially have all that dust and debris actually being blown into your process. All of those are undesired effects. So let's make sure that we take the time to clean our heaters to make sure that we can run our equipment properly, but more importantly, that you produce a quality product at the end of the day. And last but not least, the cable inspections. Taking a look at your power cables and inspecting them to make sure that you have the right size cable for the tool that you're working with. Making sure that if you do have a tool that's on a moving piece of equipment that is free from any pinch points. Making sure that all the power terminations have been properly seated into the tool. That way it doesn't come loose with any type of vibration. And one thing to point out here is it's a good opportunity when you're doing your cable inspection, take a look at the voltage as well. Get your multimeter out and take a voltage reading to make sure that you got the proper voltage going out to the tool. Why is this important? Well, let's use an example of somebody using a 230 volt 2 kilowatt tool, but only has 210 volts going out to the equipment that it's installed on. Well, what's going to happen with the power? Well, the one way that you can do that is taking just one of the simple equations of taking the new voltage of 210 volts, squaring it, and dividing that by the rated voltage of 230 volts squared of the tool, and then multiplying that by what the actual kW output of the tool actually is. So using the values that we have above, we get an example now of, instead of having a tool that produces 2 kilowatts worth of power, now we get 1.7 kilowatts worth of power. So what does that mean for our manufacturing process? Well, now you have a tool, since we have an under voltage situation, that provides less kilowatt output by 333 watts specifically. So when you think about your process, what is that going to do? Well, it could do a couple of different things. It could actually slow down your manufacturing line. Since you don't have enough heat capacity, it's going to require a longer dwell time to make sure that you put out a good quality product. And the quality of the product could be impacted. So if you have a tool that's actually providing less power at this point, you could potentially have products that are not meeting your quality specifications. More information, where can you learn a little bit more about products and processes? Well, one of the ways you can do that is through equipment providers such as Leister Technologies. So we're always willing to share a lot of our experiences that we come into contact with on a regular basis. As I mentioned before, we have 70 years worth of experience, and we're willing to share that with you to help you make some educated decisions about tools and also about your process. Looking at different trade associations. So say your company is related to the packaging industry or system integration industry. There's trade associations out there that are always willing to share different industry trends, what's going on in the market, and things to help you improve your process. And last but not least, industry innovations. Equipment providers always strive to provide products into the marketplace that can help customers improve their process, make it a little bit more efficient, provide quality products. I know here at Leister Technologies, we always strive to give our customers the best experience possible when using our tools. One important thing I would like to point out now in terms of an industry innovation, our Mistral hot air blower will be receiving UL certification. So we will have more formal communication about that within the next coming month. So please pay attention to our social media feeds such as LinkedIn and our corporate website for more information. Our YouTube channel, it's another great way to learn more about our tools and some processes. And what you can find at our Leister YouTube channel is different ways to set up equipment, different ways to run it, open loop, closed loop, different temperature settings, how to make those menu adjustments on various tools. You can find all that information on our Leister How To YouTube channel. And last but not least, our My Leister app. Now you have the capability of downloading the My Leister app to actually showcase some of the process heat tools that we have in our portfolio. But more importantly, you also have the capability of looking at those tools in an augmented reality view. So if you've got questions about how to mount a tool or what the tool looks like, or maybe you've got some dimensional things that you're thinking about and will it kind of mate into your equipment or into your process, you can always go into this augmented reality view to take a look at it to see if it's a good fit for you. And with that being said, I appreciate your time today. We do have a spot for Q&A here, so if you do have questions, please refer to the chat box, and I'll see if Joseph has any questions for us.
Yeah, so Jason, some questions that we had prior to the webinar. First one being, if you're experiencing issues with the heating element, do you need to replace the entire unit, or can you replace just the heating element itself?
That's a good question. So that's something that comes up quite a bit. And no, you don't have to replace the entire unit. All the products that we have in our portfolio, especially hot air blower, you can change that heating element on your own.
Awesome. Thank you, Jason. And then just one other question that we have right now. Still waiting to see if there's a couple more that pop up. But the second question we received prior to the webinar was, is there a separate potentiometer for the airflow control for the Mistral Premium?
Yeah, that's a really good question. Unfortunately, there is not. So what you get with the Mistral Premium is right out of the box the capability of adjusting the heat capacity from the tool itself. In terms of airflow, what you get is 100% airflow right out of the box with the Mistral Premium.
Awesome. Thank you, Jason. Doesn't look like there are any more questions at this time, so we would like to thank you all for joining us today. We certainly hope that this webinar was of value to you, and we will be sending out an email after this webinar is concluded with this recorded webinar so you can rewatch any specific segments. It'll also include some of our YouTube links and then Jason's contact info if you have any additional questions. Again, thank you so much for joining us. We hope you have a great rest of your day. Take care, everyone.